Okay, class, today is just a review day. So these problems are all problems that you've seen already. So I'm just going to go through a couple, or go through them, and so there are extra problems to look at for studying. So with number one, remember you want two things. You want the same index, which is the denominator, and you also want to break down the base numbers. Alright, so these all can have a denominator of 20, so 4 over 4 is 12 twentieths. This one would be 5 over 5, so 15 twentieths, and this would be 5 over 5, which is 5 twentieths. So now I'm going to break down the bases. So 22 is 2 times 11, so 11 to the 12 twentieths times 2 to the 12 twentieths times 6, which breaks down to 2 to the 15 twentieths, and 3 to the 15 twentieths, all over 11 to the 5 twentieths. Now that you have the common bases, you can subtract exponents with the 11s. So we have 12 over 5, which is 7. We get 11 to the 7 twentieths. We get 3 to the 15 twentieths. And we have 2 to the 27 twentieths, which means you have more than one. Since this is higher than 20, we're going to have a 2 on the outside. We're going to use 20 of them. And then we have the 20th root of 11 to the 7, 3 to the 15th, and 2 to the 7th is remaining. And that's the final answer. Number 2. I have this, I can rewrite this. Here's one thing I look at. This is the root number, and I know what the third root of negative 27 is. Okay? You should know by now, hopefully that's negative 3. Okay, so I'm basically doing that first, and then I'm going to square it. But it's to the negative 2. I'm going to keep the negative sign with the 2. So I third rooted the negative 27 to get negative 3, and now I'm going to raise it to the negative second power. Then I flip it, so I get 1 over negative 3 squared, and then when I square that, it becomes a positive 1/9. This is one where you could just type it in your calculator and math frac it and see if you get just a nice fraction. You could always check that. This one here, you need a common index. So this would be 15, so this would be 5/15, and this would be 3/15. And then if you look, you can maybe simplify these, but then you're left with a fractional exponent on the bottom, so you actually don't want to subtract here because there's a whole x down here. If you do that, you're going to get 10 on the bottom, and then you're going to have to rationalize and you get right back where you started. So really you just want to put these both under a common radical. And that's it. This one here is the 4th root of 8 over the 4th root of 25. I break these down. It's the 4th root of 2 cubed over the 4th root of 5 squared. I need to rationalize the denominator here. I need 2 more 5s. So I'm going to multiply the top and bottom by the 4th root of 5 squared. So I end up with the 4th root of 2 to the 3rd times 5 squared over 5. And then when I simplify that, multiply those numbers together, 25 times 8 is the 4th root of 200, all over 5. Okay, this one you got to break down all the way. So 1024 is 64 times 16, and I know 64 breaks down into 2 to the 6th, and this breaks down into 2 to the 4th. So this turns into the square root of 2 to the 10th is under there, w to the 14th, x cubed, y 8th, z 10. And remember, all you do is divide by the index. The index is implied 2, so if I divide this by 2, I get, these all come out, and I get 2 to the 5th on the outside. Divide these by 2, I get w to the 7th. Divide this by 2, I'm left with 1, and I get 1x outside. Divide that by 2. 8 divided by 2 is 4, so y to the 4th and z to the 5th. And then the only thing that didn't fully come out of here was this x, so the square root of x. So then you can rewrite it as 32 w to the 7th x y to the 4th, z to the 5th, root x. There you go. So that's that. Same thing here, divide each of these powers by 2. So 4m divided by 2 is 2m, plus 2 divided by 2 is 1, and there's nothing left over. That divided out nicely. We could take the square root of that, and there's nothing left under the root. Here we have to break down 36 just to check. 9 and 4, which is 3 squared and 2 squared. That actually, you can't take either of those out, so we can leave it as a 36. So I'm going to just start dividing. That divides by 3, and you're left with a to the m on the outside. Divide this by 3, you're left with b to the 4m. Divide this by 3, you're left with c to the m. That doesn't divide, that doesn't divide. Then we have the third root of 36 did not come out. The a and the b fully came out. C, we are left with 2m plus 1. And we are left with d to the m under the third root. So that's it. Same thing here, divide the powers by b. So we get x to the 12th. We get y to the 8th. That 2 does not come out, so that's going to stay in there. And then you divide this by b and you get z to the 6th. And then you get the b root of y squared, because that 2 did not come out. We'll deal with this in a second. First, let's just divide these both by 2. I get a to the 3m plus 1. I still have a to the 4m plus 1. And then I still have the square root of a to the 1st underneath it, because of this doesn't divide nicely. Combine these two bases and we get a to the 7m plus 2 by adding exponents. And then we have the square root of a. Alright, I'm going to break down 256, so I get negative 8 over, it's the 10th root of 2 to the 8th. To make this simpler, I'm going to reduce this power, because remember it's 8 over 10, which is the same thing as 5 over 4, or 4 over 5 I should say. Alright, now I need to just rationalize the problem. So I need another 5th root of 2. 5th root of 2. Can't do anything with those, so I get negative 8 5th root of 2 all over. Now there's a whole 2 because I have 5 of them. And then you can cancel out you can divide an 8 and a 2. Negative 4 5th root of 2 is the final answer. Okay, so those are some more problems to do, just for you guys to check.